ladies and gentlemen. In this review video, I'm going to be talking about how you can go from the empirical formula of a compound to its molecular formula if you already know its empirical formula and its gram formula mass. This is a type of problem that is done with empirical formula in Regents chemistry, so this should sound familiar as we go through. This should hopefully be registering something from your brain that you have in fact done this before. A little bit of a review. Molecular formula versus empirical formula. What's the difference? Empirical formula is the lowest mole ratio of elements in a compound. In water, it's the fact that it's 2 moles of hydrogen to 1 mole of oxygen. Whereas the molecular formula is the actual number of moles of elements in a compound without reducing down. The classic example is hydrogen peroxide. Hydrogen peroxide, the formula is H2O2. H2O2, in the actual formula, there are 2 moles of hydrogen, 1 mole of oxygen. This is the molecular formula, but it's not the empirical because you can reduce it down further. The lowest ratio is simply 1 to 1. That's the empirical. Now, determining molecular formula from the empirical formula. It's all about the gram formula mass. It's essentially you're figuring out the ratio between the gram formula mass of the molecular to the gram formula mass of the empirical, because that will tell you how many times larger the molecular formula is than the empirical formula. Therefore, what you need to do is first figure out the gram formula mass of both molecular and empirical. Typically, right here, in this type of problem, the molecular formula gram formula mass is supplied in the problem. They will tell you this compound has an empirical formula of, in the case of hydrogen peroxide, HO, and a gram formula mass of, in the case of hydrogen peroxide, 34. They will usually give you that information. What you will need to do then is figure out the gram formula mass of the empirical formula, because that's typically the lacking piece of information. But it's going to be easy enough because you'll have the empirical formula. You'll have the formula for the compound. You just need to figure out its GFM. Once you've done that, you need to divide the molecular formula, gram formula mass, by the empirical formula, gram formula mass. Divide the two GFMs. What this information is telling you is how many times larger is the molecular than the empirical. So it's molecular divided by empirical. It's telling you the ratio. It'll tell you is the molecular formula twice as big, 3 times as big, or maybe just the same size. Once you've figured out that ratio, is the molecular twice as big, 6 times as big, then you need to apply that ratio to the subscripts of the empirical formula to make it that many times larger. And then once you've done that, that will be your molecular formula. So sample problem, ethylene glycol has an empirical formula of CH3O. If the molar mass of ethylene glycol is 62.1, what is its molecular formula? So again, just talking about the information that's supplied to you, we have the empirical formula, CH3O. Problem is telling us that, and it also tells us that the GFM of the molecular formula is 62.1. So what we need to do is figure out the gram formula mass of the ethylene glycol. That's easy enough. The gram formula mass, hopefully, again, please do this on your own as well. Confirm that you're getting the same number as I am. Gram formula mass of the empirical formula is 31. I get 31 grams per mole. All right, so now we've got the molecular at 62.1, the empirical at 31. We're going to divide those two to get the ratio between them, the molecular divided by the empirical. And hopefully, even without a calculator, you can see that this ratio is 2. What this means is that ethylene glycol, the actual number of moles, is twice as big as the empirical formula. So we need to take that CH3O and we need to make it twice as big. The way we make it twice as big, just take all the subscripts and multiply them by 2. To give us an a molecular formula, of C2H6O2. The lowest reduced down ratio is 1 to 3 to 1, but the actual number of moles is 2 to 6 to 2. And just to go through another example with this, Second problem, the empirical formula of a compound is CH2 and it has a molar mass of 84 grams per mole. Determine its molecular formula. Again, same type of information that's been supplied. The problem tells us that the empirical formula is CH2. It tells us that the lowest reduced down ratio between carbon and hydrogen is 1 to 2. But we also know that the molecular formula has a GFM of 84 grams per mole. So we need to find the gram formula mass of the empirical formula, and we need to figure out how many times larger the molecular is than the empirical. Without a calculator, right, you could easily do this without a calculator. Hopefully you can see that the gram formula mass of CH2 is 14 grams per mole. So now we are going to compare the two gram formula masses to see how many times bigger the molecular is than the empirical. And we do that just by dividing. It's always going to be molecular divided by empirical. So 84 divided by 14, that's 6. That means that the molecular formula is 6 times bigger than the empirical. So we're going to take the CH2, the empirical formula, and we're going to make it 6 times bigger by multiplying the subscripts by 6. So instead of CH2, this is going to be C6H12. And that is a little refresher on how we figure out the actual molecular formula from empirical formula and gram formula mass information.